GM, everyone. Uh, Thanks for joining my talk about native mobile Web3 apps. My name is Jungho. I'm a software engineer at Coinbase. Uh, Actually, please note that the views here are my own, and if there should be anything to blame, it's all on me. So, why mobile? Actually, I spent some time to prepare this slide, and I realized that I expect we all came to this session because we already kind of feel or know that mobile is where the next billion users are. So probably you need me to go over these big numbers or like give you some like history lessons on how Web2 apps evolved with mobile. Actually, mobile dapps or like mobile Web3 apps are already out there. There are like social apps like Web3 Messenger like Tribes, NFT marketplaces, or DeFi apps, and the numbers are growing. And even some like Web2 giants like Twitter or Instagram, they started to like adding Web3 features to their platform. So then why are we here? So what makes building mobile Web3 apps so different? Like, isn't it just like calling some Infura or Alchemy calls instead of just Web2 APIs? Well, the biggest difference that I think on building Web3 apps is about wallet, specifically about like web to app to wallet communication. Wallet is your like Web3 identity. Dapps needs to communicate with wallet to ask users to do certain actions. So this talk is about dapp to wallet communication, especially on the like mobile devices where you have some kind of like unique constraints. And before we jump into it, let's quickly go over some existing solutions that we use with dapps on the desktop. There are like many different methods that you use, like hardware wallets or like online wallets, like MPC or smart contract wallets. But on this talk, let's focus on the most popular ones, which is like desktop wallet and mobile wallets through relay servers. So first, browser extension desktop wallet, like Coinbase Wallet or MetaMask. These browser extensions inject EVM provider and turn your regular browser into a Web3 browser. So the dapps can use this provider to communicate with wallet. And the key here is that dapp and wallet are on the same program browser or they are on the same device. So communication between the provider, the dapp and wallet is fairly simple. You can just use these kind of like web browser APIs to send and receive messages between dapp and wallet. So the communication here is direct to each other. When using desktop dapps with your mobile wallet in your phone, we are in a different scenario. Now, the dapp and your wallet are no longer on the same device. So, to communicate to each other, they need some sort of like intermediary to pass messages to each other. For example, like Wallet Link Relay Server for Coinbase Wallet or Wallet Connect. And the messages are encrypted end-to-end, so it's secure. The relay server doesn't have access to the content of the message, so it's good. And to share the information about the session, usually it uses like QR code scanning. I think it's something like sharing a PO box with your friend to talk to each other. Like Wallet Link is like a post office, and the session for the dapp and wallet is like PO box to just like pass messages. So these are the most popular method that we use currently for desktop dapps. And can we use this method for mobile dapps? Actually, yeah, it's kind of you can actually use that, and that's why we already have handful of mobile Web3 apps out there. Let me just quickly go over how they work. So first, there is a way to use the good old Windows.Ethereum on your mobile phone. Mobile wallets like Coinbase Wallet have a so-called in-app browser or a dapp browser in it. So you can just deep link into these wallets, open up your web app, run some like Web3 tasks, and get users confirmation and go back to your app and use the data. And that's actually how Twitter mobile app works. It asks the user to sign certain messages with some nonce for verification. But as you can see, the flowchart is quite cumbersome since you need to build and host a separate web app for this whole process. And this might not be something familiar to most of the mobile developers, like at least for me. And it's not suitable for like anything complex beyond some like simple tasks. Then, what about the relay server method? Actually, it seems a lot more promising because first of all, wallets already know how to talk to these like relay servers. And here, you don't need to scan the QR code because you can just deep link, you can just share this session info with deep link, and it's already like end-to-end encrypted, so it's secure. All good. Well, there's one big difference in mobile use case compared to how we use this method for like desktop dapps. So communication happens within a single device, and your phone has some constraints there. So mobile devices have quite limited support for multitasking, which means that like you can normally use just only one app at a time. And when the app gets backgrounded, the process could get suspended and you might lose connection to these relay servers. And even in like super ideal cases, requiring this kind of like dependency on the like external services could introduce like reliability issues. So, can we have a direct channel between the mobile dapp and wallet without having intermediaries? That's what I'm going to talk about today. Introduction was quite long. So mobile wallet protocol. This is a new app-to-wallet communication protocol built natively for mobile, which has this nice aspect. The first thing, how does MWP provide direct channels and making it more reliable without external dependencies? Well, it uses deep links to send messages to each other by serializing and encoding messages into some sort of like URL. So for example, here, this is some example message. It has an identifier of your app as a sender, and it has some content with requests with some like JSON RPC calls and some metadata. And MWP encodes this data into a string and appending it to deep link URL of recipient. So that's it. Problem solved. Except deep links are not secure at all. If you're curious, yeah, you may like Google this, like you may read more about it, like URL hijacking. But earlier I said that MWP is like secure, so how can you ensure security? Actually, what does it even mean by being secure? So I think it's about ensuring authenticity and confidentiality. Authenticity is about, from the perspective of the recipient, you should be able to verify the incoming messages is actually coming from the sender. Well, this problem sounds quite familiar to all you like crypto folks. It's quite like well-known problem in cryptography. You may just use like message signature, or in MWP we use something called Diffie-Hellman key exchange. It might sound a bit overkill, but first let me just try to explain it in 10 seconds. Each peer generates key pairs. By the way, the keys I'm talking about here is nothing to do with your Ethereum account. It's just like pure generic cryptographic keys. So gold keys here are private ones. Client has circle ones, wallet has rectangular ones. They first exchange their public keys with each other. It's safe because it's just public keys. What Diffie-Hellman gives us is that by using your private key and public key of your peer, both of you can derive the same identical key on their own. So since these peers now have a shared secret, they can just encrypt and decrypt messages between them, and they're the only ones who can do so. So nice. You can derive a same shared key. So with that, we can ensure authenticity. Recipient can just check whether the message can be decrypted with the shared secret that you have. Confidentiality is in opposite direction. Sender should ensure that the message is kept secret and accessible only by the recipient. Well, actually, we already solved this. Like, you can use the shared secret from this whole like Diffie-Hellman stuff and encrypt all the messages. So you can ensure that only your peer can decrypt this. But there's actually one more thing about confidentiality. You don't want to send this message to some random apps. Even though they cannot decrypt this, you just want to make sure that the message is going to reach to the intended recipient. How can you do that? Actually, this problem as well has been also addressed in like mobile operating systems. It's called universal links on iOS or app links on Android. So instead of using like custom schemes, you can just use your domain to receive deep link messages. It works like this. So when my app claims to the OS that, okay, from now on, I'm going to handle all the links to myapp.com within my app. And then the operating system needs to verify whether that is a like valid claim. To do that, it goes to that domain and check whether the domain actually hosts this kind of like configuration file to prove that my app indeed controls the domain. So that's how MWP ensures security. But actually, okay, now you can have a like shared secret, but I didn't talk about like how you're gonna actually, how does a wallet decide to grant key or not with what kind of like criteria? Well, first you need to get user's confirmation, but what kind of client information should the wallet give to the user to help them make such a decision? We already have this. For desktop dApps, it works like you show confirmation pop-up like this, and it shows the domain of the dApp, like vlook.io. And if the domain looks suspicious, like vve100k.io, users would not approve this. And actually, I already talked about like using domain for verification purpose several slides ago for like using universal links. So like OS use this, why not wallet would use this one? So this domain verification method is pretty simple. You just go to the domain and check whether the config file is there. So the client app can prove that indeed controls the domain. So wallet just would ask the user whether they are okay to respond to this domain. What's nice about this approach is that like wallets just can be used as like same user confirmation flow they already use for like desktop web dApps. And this whole process is like truly decentralized. Like all you need to like prove yourself authenticity is just like hosting some config file on your domain. And we don't need any sort of like centralized registry to have like a list of apps or a wallet. So we call this process of like client acquiring permission from wallet as Handshake. So on this like sample Handshake message, the sender field here is actually a public key of the app, and you pass your like universal link domain, which will be used for callback and authenticity verification. And on the wallet side, it checks whether the domain is actually configured for this client app. And if it's actually valid, it asks for user's confirmation. And if user allows, the wallet creates a key pair for this session. And with the public key of the client app, wallet can drive a shared key. Then, wallet sends back the response along with its own public key, wallet's public key, and the content of message is encrypted, and it can be read only by the peer who made the request. So upon receiving the response, client can also derive the same shared secret using its own private key and the public key that you got from the wallet. So MWP is secure, and it has more nice aspects too. First, it's optimized for mobile UX. It allows something called batch requests. You can make a request with multiple actions. Action is JSON RPC call. Actually, I have to say the credit goes to John at DYDX. DYDX was one of the first apps, tried our new SDK, and this idea of batch requests is solely his idea. It enabled huge improvement in UX to just reduce number of app switching. So thank you so much, John, for your contribution. And it's also easy to use, strongly typed. It has nice auto completion, but I'll just move on. And the protocol is now implemented in all major developer platforms, like Swift for iOS, Android, React Native, and Flutter. And also, I have to say, it was possible by massive effort by many engineers in Coinbase and by the community as well. Hish at Tribes built Flutter library for us and gave us great feedback on the protocol. And I have to give huge shout out to Vishnu, my colleague. He not only built the libraries for Android, React Native, and host libraries for Wallet, he also helped me refine the protocol so that it can work on not just iOS and on Android as well. So thank you all for your contribution. So you can find these implemented SDK, client libraries on all major dependency management systems like CocoaPod, Maven, NPM, so on. And we also provide a host library for Wallet. It's available on React Native. And yeah, it's actually used by Coinbase Wallet as well. They're all fully open source, and the spec is also available as well. Looking ahead, we expect to see more wallets coming. Coinbase Retail MPC wallet is going to support this soon, and we are also talking with other wallets as well. We are going to add support for mobile browser as well, because any web app which can just send and receive deep links, you can use this one. And also, I'm looking forward to seeing more new mobile Web3 apps built by all of you. So that's mobile wallet protocol. Direct and more reliable, ensuring security with cryptography and some mobile technologies. It's fully decentralized. It has batch request support, and it supports multi-chain. I didn't mention that, but it supports multi-chain, chain agnostic. If you want to learn more, just come say hi at the home base booth, or you can reach out to me at Twitter or jungho.eth. So looking forward to hearing from you. Actually, one more thing, and little PSA from Coinbase Wallet. We want to learn from you how we can serve you developers better. So please fill out this form. You can just scan that or just come to our booth, and we will send you some free test ETH. So that's it. Let's build for next billion users. Thank you.